A few days ago, I posted an Instagram reel in which I drank 1 litre of chocolate milk in under 10 seconds. On that Instagram reel, a lovely man by the name of Sax_ON24 told me I should poke a hole in the top of the carton because then I wouldn't have to crush it with my hands and could save time. This got me thinking, and maybe thinking a little too much. How fast could I, unassisted, theoretically drink 1 litre of chocolate milk, and then also with a high pressurised chocolate milk gun, what is the human limit? And I've figured it out. So, let me show you. Drinking is essentially just a fluid dynamics problem. You have your container of chocolate milk, and you want to transfer this to your throat. Now, in order for something to happen in physics, you need a force. Nothing happens without any force. So, assuming we're drinking the chocolate milk like this, one of the forces that is going to be acting on the milk that makes it go down into our throat is going to be gravity. Perfect. And another thing that makes liquids move, they move from high to low pressure. You will have seen this before if you don't know off the top of your head, but think about when you blow up a balloon. It's really difficult to blow up a balloon because it's quite high pressure and the air is pushing back at you, and then if you're holding it here, as soon as you let it go, it explodes everywhere because all the air escapes back into the lower pressure atmosphere. And yeah, liquids and gases move from high to low pressure. There is one more sneaky force that's kind of going on here, and it's sort of a force, not really, it's suction. If I suck harder, pause, Jesus, the milk will come into my throat faster. That also sounds weird. But this is basically just making the lower side of this way, way lower, because when I suck in my cheeks, I create lower and lower pressure, while also mewing. Because the change in height is so small here, the force due to gravity is essentially negligible. So we can now just calculate the velocity of this liquid to figure out how fast we can get it into our mouth from the change in pressure. And those are all using values that we know because someone somewhere in the world has shot a high pressure hose pipe or something at some poor person's mouth and figured out at what point their skull just exploded. So the first equation is going to be our flow rate. We want to find how fast we can get this chocolate milk into our mouth, and that's just the rate of the flow. That's why it's called a flow rate. That depends on two things. Things have a very high flow rate. Imagine a huge lake. Even if it's moving very, very slowly, you have tons and tons of water just coming at you all the time. And so it's going to be dependent on the area and the size of the water that's just coming at you. Or chocolate milk in our case, a big chocolate milk lake. And you can also have a little tiny Mary chocolate milk stream coming at you very, very fast. And so if you stood in front of that, you'd still get tons of chocolate milk at you, all because it's flowing so fast. It's also dependent on the velocity, therefore. And that's completely it. Our area is going to be the area of our throats. The average human throat diameter, I had well fun Googling this, was 2.5 centimetres. So, if this is my cross-section of my throat, this is 2.5 centimetres. Pi r squared gives you the area of a circle. R is going to be that halved. And then it's going to be whatever that is in meters. I'll find it later for you. So that's the area bit of our equation solved. Now we just need the velocity. And because we're fun, we are going to start off with the theoretical maximum. If I had a high pressure, just super power gun and firing it from like over there just into my throat, like how much pressure could I withstand before my head just got torn off? And that is this equation here. Bam. V equals the square root of 2 times the difference in pressure divided by the density of our liquid. And this kind of makes sense intuitively the same way as this one did. If I have a very high difference in pressure, this top of the fraction is going to be very big, which means that this is going to all increase. If I have a huge difference in pressure, if I shake up my Coke can, or if I blow the balloon more and more and more, and then I release it, it's going to come out with a faster velocity. Makes sense. And if I had a very gloopy liquid that was quite dense and maybe sticky, that is going to slow it right down. And so that's where that equation comes from. The soft tissue at the back of your throat can withstand a maximum pressure change of roughly 1 atmosphere. 1 atmosphere, the weight of all of the air on top of you right now, is 100,000 pascals. That means this number right here, well, it's not a number right now, this little symbol is 100,000. The density of chocolate milk, the density of water is about 1,000 kilograms per meter cubed. The density of milk is about 1,030. And the density of chocolate milk, because of all the sugar and added fat and just awesomeness, because like the amount of awesomeness in chalky milk has to come from somewhere, brings it up to a nice 1,200, 1,300, which is going to slow us down a fair bit. It'd be easier to do it with water or easier to do it with milk. This means also if we're selecting the chocolate milk, we might want to go for one that has slightly less sugar and slightly less emulsifying fat in it. So we can call that like 1,200. And now we can find our velocity. And then from that, we can find our flow rate. And our flow rate will tell us how many litres of chocolate milk we are consuming per second. And then we know we need to drink 1 litre. And if this tells us we consume 1/4 of a litre every second, we know it will take 1, 2, 3, 4 seconds to consume 1 litre. And that will tell us the theoretical limit of how quickly you can consume 1 litre of chocolate milk. The area of a circle is equal to pi r squared. We can figure out that the area of the cross-section of your throat is about 4.9 times 10 to the minus 4 meters squared. For the velocity of this theoretically super high pressure chocolate milk, we have 2 times our 100,000 divided by 1,250. This is equal, as my little computer in the corner is telling me, to 12.6. So, when we multiply this, and this, we get a flow rate of about 6 litres per second. By the way, this is like motorway speeds. This is 12 meters per second, like 12.6. Let's not like diminish it in any way. This is sick. I don't know how you reach that, but I mean, there's definitely a way. Maybe vaporizer, but then you'd have to like take into account. You don't like burn the back of your throat. We'll get engineering on it. We'll get an engineering team on it. 6 liters of chocolate milk Okay, that's like, I don't know, what's that? So we only need 1 litre, so we don't need the full second. We need a sixth of it. That is going to be 1/6 recurring. So 0.17 seconds. There you go. That's the limit. The human limit. If we had this atmosphere of pressure gun and we poured chocolate milk in the top and I aimed it at your throat and you were like, I don't know, perfectly flat aligned, ready to receive the chocolate milk, it would take me less than a fifth of a second. And that just does not, my 9.49 seconds does not compare at all to it. Unfortunately, we don't have the chocolate milk gun right now. If we did, I'd just be spraying it around everywhere. But what's the best I can do with no, and you can too, with no assist, no wrist wrap equivalents, no straps, elbow wraps? Do elbow wraps count? I don't think wrist wraps do. This is like a philosophical little question for you. Where do you draw the line? I think the slingshot ones, that's where I would be like, yeah, that's too much. Anyways, I diverge. The area of our throat is going to stay the exact same. That was 4.9 times 10 to the minus 4 meters squared. There we go. But our velocity is pretty safe to say the fastest you're going to be able to chug a Choccy milk is just from like physiological stuff. The speed you're going to be able to get it to are maybe around 1 meter per second. And so anything times 1 is just itself. And then when we convert this all into litres, we find that we can get about half a litre of chocolate milk per second as our flow rate, which is a bit underwhelming considering we had just such a huge flow rate before of 6, and now just at 0.5 we're at a twelfth of that. And this means that if we need to drink 1 litre of chocolate milk and we can do half of that per second, it's going to take us 2 seconds. Yeah, big new whiteboard pen. So there's a pretty big disparity between those two, but there's also a huge disparity between my best time so far of 9.49. Now I know that the elite level naturally would lie here. I am tempted. Well, I was going to say it like I'm not going to 100% do it and haven't had my mind on it this entire time, otherwise I wouldn't have done all this. I'm going to get that. We're going sub 5. Sub 5 is what I want to do. Imagine you're at the gym and you've left your chocolate milk out, or just anywhere. Because remember, chocolate milk is quite a gloopy liquid. If you've poured some varieties of it out, oh my god, they are gloopy. Imagine you leave your drink out, or just anywhere, and I'm around, I see it. A full litre of chocolate milk right there. And then you go to tie a lace. It's gone. You look back up. What? The carton's here, but it is empty. Your brain would not be able to comprehend that I had drunk it, because in that short amount of time, I wouldn't have been able to, unless I had done my Choccy milk physics and knew that it was possible. So there's only one thing left to do now that I know about the stabbing hole in the top tech and maybe a few different little strategies. See how close I can get to the 2. I don't want to do that.
bad it was, but thank you, Saxon.